What?
It started, mister. It starts recording.
Okay.
It's now recording.
No problem.
Yes, now record.
So all is okay till now, guys?
Yes, yes.
Okay, great. Now you can make a small difference between a scalar and a vector. So next year, guys, in grade 10, you will take scalar and vector in details. There is a special lesson about vectors, okay, so that you can differentiate them. But I want from you now to know the difference between scalar and vector. It's so easy, guys. Just if I have a direction with a magnitude, it is a vector. If I have a magnitude without a direction, it is a scalar, and that's it. Okay? When I specify the direction, so the scalar will become a vector. Without specifying the direction, so a scalar is a scalar. Okay? So time is a scalar, guys. When we say it's 4 minutes, 5 minutes, 7, without specifying any direction or anything, it's a scalar. So almost time is a scalar. The difference between two intervals is called, what do you call that? The difference between two intervals. For example, if I start my class at 9 and I finish my class at 9:45, so the time between the two intervals is what, guys? What do you call the time between two intervals?
Time interval.
Excellent. We call it the time interval. So the time separating two, a starting and the ending point, initial and final point, we call it the time interval between 2 points. So if I'm going from Jeddah to Riyadh, I start my journey at 7 o'clock. I reach Riyadh at, for example, 12 o'clock. So 12 p.m. So the time interval is 12 minus 7. I will get it, for example, it's from 7,
5
8, it's 5 hours.
hours.
Okay, so this is the time interval. We call it delta t. So delta t is equal to t final, that is 12, for example, minus t initial, that is 7. So 12 minus 7, that we get 5 o'clock, or 5 hours. Okay, this is delta, guys. Delta is a Greek letter, delta. It is used to represent a change in a quantity. We will use delta so much, guys. Okay, delta t, delta v, and you will see it later on. Okay, so do you can now tell me what is delta t, guys? It's clear what is delta t?
Mister, I'm somehow confused.
About what, Abdurrahman? Let me
Hadi,
know.
not Abdurrahman. Hadi, Muhammad Hadi.
Oh, Hadi, where is you, Hadi? I can't see you.
So because they are raising their hands.
Okay, no problem, no problem.
Okay.
Hadi,
Yes.
about what you are confused?
About
You can please, about what? Can you tell me about the time interval?
but from when you started from the time intervals are scalars. Absolutely, I don't understand.
Okay, great. So I will repeat from here. When I want to say that time first of all, it's okay for you that time is a scalar, because we cannot say, for example, we cannot say time and put for it a direction. So there is no direction to time,
Yes,
for example.
of course it's
So
scalar.
time is a scalar, guys. But when we want to talk about the difference between two times, the difference between, for example, and leaving the class, interval of time.
Mister, your
Okay,
sound
so this
lagging.
interval of time,
Mister, your sound was lagging. Where?
what? I
Your
can't
voice is lagging.
understand.
Your your internet is bad.
Now it's better. You can hear my voice now.
Yes.
Yes,
Okay.
sir.
Okay, so the time, guys, the time interval between between, for example, and attending the class and leaving the class, we call it the time interval. So how can I find the time interval mathematically? I will get delta t by subtracting the time final, the time leaving the class, for example, minus the time attending the class, the time initial. So I will get the time interval, the separating time between starting and finishing the class. This is how we can know what is the time or the scale, the time that is a scalar. Okay, the time interval between two intervals. Okay. Now displacement. We know what is a time. Now I want to know what is the displacement. That is x, guys. X that we know it here. This is x what that we study about it here, guys. Okay. So this is x. Now I want to know the displacement, the different also when I am talking about displacement. So I will talk about delta x. So I know what is delta t. Now I want to know what is delta x. A change in position is called a displacement. So when the position is changed, so I will say that there is a displacement. Let's say here, guys, this is xi. So the x initial here is from 0 to 5, and x final is from 0 to 25. There is an example here. So what will be x delta x, guys, here? Delta, can you see delta x?
Yes, Mr.
Yes,
Can.
mister, yes.
Mr. Ashraf.
Guys, can you hear me now?
Yeah.
Yes, yes. No, yes.
Yes, yes, mister.
Okay. So here, when I want to talk about displacement, please mute yourselves, you guys. So when I want to talk about displacement, first of all, displacement is a vector. Why displacement is a vector? Because it is a subtraction of two positions. So the position is a vector and the position have a direction. So of course, displacement will have a direction. So displacement is a vector. So a change in the position is called a displacement. Displacement is a vector. It is drawn with its tail at the earlier position and its tip at the later position. You all know what's the tail and what's the tip. This is the tail of a vector and this is the tip of a vector. Tail and tip, or we call it head and tail. Okay, so displacement can be represented mathematically. How can I represent mathematically the displacement? I can represent it by delta x. So what is delta x, guys? Is the same as here we say delta t is t final minus t initial. Here the same. Delta x is x final minus x initial. Okay, guys, please, I want from you all to take notes. You may use these in the assignment. Okay?
Okay.
Okay. So this is how can I find the displacement between two points. X delta x is it's x final minus x initial. So this is x final, let's say. This is x initial. There is the subtraction of these two vectors will be from 5 to
Can you
25.
show
So
the one before it for T?
yes, this is
Okay.
40.
Thank you, miss.
So delta t, it will be t final minus t initial. Okay, and delta x will be x final minus x initial, and that's it. Here some examples. Here, for example, we have x final is 25, x initial is 5. So 25 minus 5, it will be from 5 to 25
20.
is
So
20.
delta x is 20.
Excellent. So delta x is 20. And do not forget to put the units, guys, okay? Always. So vector addition now. So how can I add vectors? You can you can say, guys, that vectors, when I want to add vectors, sometimes vectors will be, for example, an opposite direction. So what shall I do if I have two vectors but having opposite direction? Okay, when two vectors have opposite direction, instead of adding them, I will subtract them because they have opposite direction. But with respect to you, you are asked for the vectors of same direction. Okay, here a vector that represents the sum of two other vectors is called the resultant of the two vectors. You will memorize this word, resultant of two vectors. Okay, draw the vectors tip to tail. Always when I want to add them, I will draw them tip to tail. Okay, or head to tail, and another time head to tail with respect to the second vector, and then I must add them. Okay, here for example 5 kilometers, and can you see here, guys, east? What is east? East is the direction of the vector. And here also 2 kilometers east, so it is the resultant will also be here to the east, the resultant will be also east. So you know, guys, what is, how can I add two vectors when they are parallel? Of course, when they are parallel and having the same direction, I will say that 5 plus 2, it will be 7. Here, vector A is going to the east, vector B is going to the east, then the resultant R will go to the east. So R will be A plus B, it will be 7 kilometers towards the east. Okay?
Okay.
Here, if there is, for example, here another example, but see here, guys, vector adding addition, but you try it here with one way they have opposite direction, guys. If A is 4 kilometers, this is an important example. A of 4 kilometers, this is A, from the origin to 4 kilometers. Yani, suppose one of you here, guys, take a walk for 4 kilometers to the east. They reach this point. Okay, they returns back another time. They returns back, and they returns back, guys, by what? Let's say here. Okay, this is the example. Here
2
from the
meters.
origin, let's say some of you take a walk, for example, 4 kilometers. They returns back from this point by 6 kilometers to the west. So what shall I do, guys, to have the resultant of these two forces? So 4 kilometers east is plus 4, okay? But 6 kilometers to the west, it's minus 6, okay? So when I want to add them, I want to put 4 minus 6. So 4 minus 6, it will be 4 minus 6, it will be minus 2. But why here I put 2, guys? Because I'm putting here the direction west. I know that the direction west give me the negative direction, because if I'm here, I have the resultant here, the origin. Every value going to the left is negative. So if I put here the resultant in the system, I put R equal 2 kilometers to the west. Okay, or I can put it 2 kilometers or minus 2 kilometers, but I put east. You get it, guys? How can I subtract two vectors when they are going on the opposite direction?
Yes, sir.
Yes.
Okay, great. Now here another example. Okay, try it, all of you guys. If A is 7 kilometers, this is A. From origin, we go 7 kilometers east. This is the east, okay, guys? And we have here A is 7 kilometers east, and B is 4 kilometers west. This is B. So what is the resultant now? It's 7 minus 4. So 7 minus 4 is what, guys? So 7 minus 4 is 3 kilometers to the east. Excellent. Why to the east? Because 7 is greater than 4. Here, guys, when we have here, guys, let's say we are going 4, but 6 is greater than 4, then we are going on the opposite direction, so 2 to the west. But here,
Mister.
because 7 is greater than 4, then 7 minus 4 will be 3 kilometers to the east. This is the
Sure.
resultant from the origin to the east by 3 kilometers. Okay? You have a question?
Mister,
What?
if we put
No.
like -3 km to the east, it's correct or wrong?
Here, in this case?
Yes.
Hello, Mister. Can you hear me?
Yes, I can hear you.
Can you repeat it again?
Yes, I will repeat. Guys, here if I have to add, I will repeat, and you may maybe you will get the point. Here, guys, I will repeat from the beginning. If I have two vectors having the same direction, okay? Having the same direction, it means that first of all, I move 5 kilometers to the east and another 2 kilometers to the east, then I will add them, just adding 5 plus 2. You get it? So 5 plus 2 is 7 kilometers. Both them are to the east, then it's sure it will be to the east. The resultant will be going to the east because both of them are to the east. Okay? It's clear for the first one?
Yes, Mister.
Okay, the second one here, guys. See the origin. Here, the 0 origin. I go from the origin, I go 4 kilometers to the east. Okay? This is the first vector. But when I reach here, I return back by 6 kilometers to the west. So 6 kilometers to the west is negative, guys. I'm going in the negative direction. Because 6 is greater than 4, then the resultant will be to the west and not to the east. I compare 4 by 6. If 4 is greater than, if the east value is greater than the west, then the resultant will go to the east. But here, guys, 6 kilometers is greater than 4. Then the resultant will go to west or east?
West.
West.
Excellent. So
West,
here,
west.
one I compare the two values. 6 is compared with 4. 6 is greater than 4. So the resultant will be to the west. Here, guys, who's greater, east or the west? Here we have 7. Here we have 4.
East.
East.
So east is greater, so the resultant will be 3 kilometers east. And that's it. You get it now?
Yes, Mister.
Okay,
Yes.
guys, great. Now it's 12:20. Okay. Now I want you guys, thank you for today. I want you directly to go to your assignment, submit for it. It is so easy. Okay. If you have any question, please, before submitting, let me know. Okay.
Okay, Mister. Thank you.
While you are submitting while you are working on your assignment, please, I want from you all to open your cameras.
Mister, may you put the assignment?
Yes, I posted it. It will take 1 minute. So if you have any question, please let me know. Guys, open your cameras. Hurry up.
Mister, may you repeat what the scale is? That the scale.
Scalar. You mean scalar?
Scalar, yes, scalar.
Scalar one, we have a magnitude without a direction. It's a scale. Yusuf,
Without direction, okay.
where is your nice smile, Yusuf? I missed it. All of you guys, hurry up. Open your cameras. Kareem. Kareem always opening his camera as if he is in a studio, but now I didn't know why he didn't open his camera. So can you see now the assignment, guys?
Mister, I have a question, Mister.
Go for it. Ask Hadi.
It's an assignment or test. Yeah, Mr. Hard. What's
Hard.
this? Oh my god. I will take zero.
From your teeth, it's not seem that it's a hard assignment. You are smiling. If you have any question, ask. Kareem, you took less than a minute to finish your assignment. Why? Take your time, guys. Take your time. It's not a game and
What,
clicking.
mister?
You count for 5 and حكرة بكرة قال لي ربي أدلى العشرة. Please.
Mister, I don't submit my assignment.
You didn't submit, Kareem?
Oh, okay, Kareem. Okay. I think me, mister.
Kareem, not Walid. Kareem. If you have questions, please ask.
Mister, I have question.
Which question?
Mister, what means displacement? What is displacement?
The displacement is the distance. Is it just the distance between 2 points, or it needs a direction to be a vector?
It needs a direction to be a vector.
Yeah, it means that the length of a path is a distance and not a displacement. You get it? Yes.
Mister, I
Yes.
finish.
Okay. When you finish, you can leave, guys. Have a nice day. Nice to meet you. Nice to see you all. Have a nice day. Bye bye.